Doxford engines powered Britain's merchant fleet for the best part of the 20th century, designed and built in a single works on the south bank of the Wear, in a town that most of the shipping world couldn't have found on a map. At its peak, Pallion employed over 7,000 workers. 25 manufacturers across the globe built Doxford engines under license. During the war, those engines pushed the convoys that kept the country fed. They survived 2 world wars, survived the Depression, survived foreign competition that wiped out half of British shipbuilding. They retooled, innovated, and kept the gates open through everything the century threw at them. And then, after 148 years of building, the works went silent. How does the only marine diesel ever fully designed in Britain simply disappear? What happened at Pallion? Chapter 1. The Shipwright of Cox Green. The story begins where the Wear narrows, 6 miles upstream of Sunderland proper, in a place called Cox Green. It begins with timber, with a river, and with a man who had no reason to believe he was building anything that would last. William Doxford was born on the 1st of March, 1812, at Bishop Wearmouth, the son of Joseph Doxford and Elizabeth Chapman, neither of them gentry, neither of them wealthy. The family were timber merchants, which on the Upper Wear in the 1830s meant something specific. You knew wood, you knew the river, and if you had any ambition at all, you built ships. Wooden ones, small ones, the kind that carried coal downriver and crossed to the Baltic and back if the weather held. He married Hannah Pyle on the 23rd of April, 1834. The name Pyle would echo through 3 generations of the family. Robert Pyle Doxford, the engineer's son who would one day change everything, but that was decades away. In 1840, William Doxford built his first commercial vessel at Cox Green, a little wooden ship, nothing remarkable, launched into a river that already carried more hulls per mile than almost any waterway in Britain. He'd chosen a brutal moment to start. Shipbuilding on the Wear was ancient. The first recorded builder was Thomas Menville at Hendon in 1346, but it was also viciously competitive. By 1814, there'd been 24 yards on the river. By the year Doxford launched that first hull, there were 65, crammed along both banks, fighting for the same orders, the same timber, the same skilled hands. And then the decade turned savage. More than 30 Sunderland yards went under in the 1840s, wiped out by a slump that crushed wooden shipbuilding across the northeast. Doxford survived. The sources don't say exactly how, whether it was better costs, thinner margins, a willingness to take orders nobody else wanted, or simply the stubbornness of a man who'd bet everything he had on a single berth by the river. What they do say, consistently, is that the survival itself became the family's founding myth, the proof that Doxfords endured, that when the trade killed weaker men, the Doxfords kept the gates open. He stayed at Cox Green for 17 years before the move that defined the firm. In 1857, Doxford relocated downstream to Pallion on the south bank of the Wear, taking land adjacent to Pallion Hall, the same house where Joseph Swan, the inventor of the incandescent light bulb, had been born. Maps of the period show the site sitting on the very fringes of Sunderland itself, where industrial urbanism met the traditional fields and farms, stretching westward to Hilton. Within a generation of Doxford's arrival, those fields would be gone, swallowed by the yards, the engine shops, the terraced streets that grew up to serve them. The timing was deliberate. The Wear was changing. An Act of 1717 had deepened the river for coal traffic, and by the Napoleonic Wars, Sunderland was Britain's 4th largest port by tonnage, behind only London, Newcastle, and Liverpool. Ships built on the Wear were known locally as Jamies. By 1850, 2,025 shipwrights worked in the town, with another 2,000 in related trades, and the Sunderland Herald felt confident enough to proclaim it the greatest shipbuilding port in the world. Between 1846 and 1854, almost a third of all British shipping was built on this single river. That wasn't puffery. It was arithmetic, and Doxford at Pallion was building to match the river's ambition. 2 of his sons joined the firm, William Theodore, born 1841, and Alfred, but it was the 3rd son who would prove decisive. Robert Pyle Doxford served his apprenticeship not at the family yard, but at the North Eastern Marine Engine Works under Sir William Allen, learning the trade of the marine engineer rather than the shipwright. In 1878, Robert persuaded his father to add an engine and boiler shop on the Pallion site. It seemed like a modest decision at the time. An engine shop, a few extra buildings, a capability that would save the yard from subcontracting its propulsion to outside suppliers. But it was the decision that, 3 decades later, would carry the firm into the diesel age, and make Pallion the only shipyard in Britain that designed, built, and installed its own slow-speed marine engines from a clean sheet. Every yard on the Wear bought engines in. Doxford made them. William Doxford Sr. didn't live to see what that engine shop would become. He died in 1882 with his 4 sons, William Theodore, Alfred, Robert Pyle, and Charles David, taking control in partnership. But the yard he left them was already formidable. In 1864, they'd moved from wood to iron. In 1870, a much larger 5-berth West Yard had been laid down. From 1872, Admiralty orders started flowing in. Composite gunboats first, then in 1875, the corvette HMS Magician. By 1879, they'd built the Grecian, at 4,500 tons, the largest steamer afloat. A working shipwright who'd started with little wooden ships at Cox Green had built, in 42 years, the largest private shipbuilding works on the Wear, and his sons were about to make it famous. Chapter 2. Iron Turrets and the Blue Ribbon. William Theodore Doxford was not his father, where the founder had been a practical man, timber, hulls, survival. The son was a Victorian polymath, educated at Bramham College in Yorkshire, knighted by Queen Victoria at Osborne House on the 9th of February 1900, and, in 1895, the first Conservative to win a Sunderland parliamentary seat in 40 years. He was also, in a period of bitter industrial relations across the North East, an explicit and public supporter of the trade union movement. He helped to make a success of the Sunderland Conciliation Board, established in 1885, gave evidence to the Royal Commission on Labour in 1892, and stated his belief, on the record in front of commissioners, that the stronger the unions are, the less likely there will be strikes. Doxford men, then and for decades after, took that as the family creed. It was unusual for its era. It was also shrewd. Pallion's industrial relations were better than almost any yard on the river, and the reason was structural. The family had decided, explicitly, that organised labour was an asset rather than a threat. In 1891, the firm incorporated as William Doxford and Sons Limited with a capital of £200,000, every share held within the family. Their best customer was the Clan Line of Glasgow, and it was for Clan Line that Doxford produced his most eccentric design, the turret deck steamer. Patented in 1892, the turret ship had a narrow superstructure, about 5 feet wide, roughly half the breadth of the hull, superimposed on a conventionally proportioned lower body. The idea was to reduce tonnage measurements and therefore port dues while maximising cargo capacity below. Lloyd's underwriters took one look at the design and refused to insure it. The stability characteristics were, to put it gently, questionable. Doxford's response was pure Victorian brass. He set up his own shipping company, the Turret Steam Shipping Company, built the prototype himself, and sent it to sea loaded with patent fuel and railway iron on a voyage from Cardiff to Tampico. It worked, mostly. Clan Line ordered 30 turret ships. 2 of them, the Clan Ranald and the Clan Gordon, were later lost because of the design's poor behaviour at large angles of roll. But by then the order book was full, and the turret ship had established something more important than itself. The principle that Doxford didn't just build what others designed. Doxford innovated. Doxford took risks that the underwriters wouldn't touch, and sometimes, not always, but often enough, made them pay. Between 1904 and 1907, the firm added an east yard and 3 further berths, giving Pallion a total capacity that dwarfed anything else on the Wear. And then, in 1905, something remarkable happened. Doxford won the Blue Ribbon, the unofficial prize for the highest output of any shipbuilding yard in the world. 20 vessels launched that year, 86,532 gross tons in 12 months. The following year they pushed it higher still, 106,000 tons. No yard on the Clyde matched it, no yard in Belfast, no yard anywhere. By 1914, the firm was advertising itself as builders of all types of steamers up to 20,000 tons dead weight, torpedo and other high-speed vessels, either with reciprocating or turbine engines, patent belt discharging vessels for coal or ore, internal combustion engines and floating oil storage. that final phrase, internal combustion engines, was the future, and it arrived in the person of a Swiss engineer who would give Pallion its masterpiece. Chapter 3. The Swiss Engineer's Engine. Karl Otto Keller was born in Switzerland in 1877 and arrived at Pallion in 1906 as chief designer. He was 30 years old, he'd been hired to solve a specific problem, how to move beyond steam, and he brought with him a deputy called W. H. Purdy and an appetite for experiment that the Doxford board, to its lasting credit, chose to fund rather than contain. Keller and Purdy tried gas engines first. They abandoned that line. They switched to diesel, and in 1911 built a single-cylinder crosshead engine, 250 brake horsepower at 130 revolutions per minute, with a 19.5-inch bore and a 37-inch stroke. It ran. It also exposed structural weaknesses around the cylinder heads that made it commercially useless. What Keller did next was the decisive technical leap. He pivoted to the opposed-piston principle. Instead of one piston compressing fuel against a fixed cylinder head, he used two pistons facing each other in a single cylinder, with combustion happening in the space between them. The engine had no cylinder head, no valves in the combustion chamber. It was uniflow scavenged through ports cut in the cylinder liner, which meant the gas flow was clean, efficient, and mechanically simple. The lower piston connected directly to the crankshaft below. The upper piston connected to it through two side rods. The result was an engine that ran smooth, burned the cheapest fuel a refinery could produce, and could be scaled to enormous power outputs. Construction of a new single-cylinder prototype began in 1913. 500mm bore, 750mm equal upper and lower strokes, 450 brake horsepower at 130 revolutions per minute. Testing started in July 1914, just weeks before Europe went to war. That November and December, under the continuous supervision of Lloyd's Register surveyors, the engine completed a 35-day full-power endurance run that more than met the company's expectations. The Doxford opposed-piston marine diesel was proven. The First World War delayed commercial production by half a decade. The yard turned to destroyers, 21 torpedo boat destroyers during the conflict, and 19 standardized war-type merchant ships. Sir William Theodore Doxford died in 1916 at his home at Grindon Hall, a few months after his wife Margaret, having spent 34 years in overall charge of the firm. He didn't live to see his engine go to sea. The first full-scale Doxford oil engine, a four-cylinder unit, 580mm bore, designed in 1919, went to sea in 1921. Each cylinder produced nearly 500 brake horsepower. The engine operated with airless fuel injection, rather than the original air blast system that Rudolf Diesel himself had patented, which made it simpler, lighter, and far more practical for shipboard use. By 1924, Keller and his team had produced the engine that would define the firm for the next half-century, the three-cylinder economy engine. It was, as the name suggested, built for thrift. 3 cylinders, modest power, exceptional fuel economy. Exactly what a British tramp ship owner wanted. An engine that could push a 10,000-ton cargo vessel across the Atlantic on 6 tons of fuel per day. Nothing else in the world could match that figure. The economy engine became the default power plant for the British merchant fleet, and it did so at exactly the moment when Britain's merchant fleet was the largest in the world. The licensing program that followed was the commercial engine of Doxford's golden age. By the end of the 1920s, the company had 4 British and 2 overseas licensees, each paying an initial fee of £10,000 plus a royalty of £1 per brake horsepower. By the 1930s, at the technology's absolute peak, Doxford designed or Doxford licensed engines powered approximately 90% of the world's diesel-driven merchant ships. The licensee network eventually numbered 25, including Hawthorne Leslie on Tyneside, Sun Doxford in the United States, and Chantiers de Provence at Marseille. 25 manufacturers, a global monopoly in all but name, and every drawing, every design calculation, every innovation in piston geometry and fuel injection and scavenging efficiency originated in the same engine works at Pallion, on the south bank of the Wear, in a town that most of the world's shipping executives couldn't have found on a map. It was the only major slow-speed marine diesel design ever fully developed in Britain. The only one, and within 50 years of its peak, it would be extinct. Chapter 4. The convoys. The Second World War made Pallion legendary, and the reason was arithmetic. Between September 1939 and the end of 1944, the yards of the River Wear launched merchant tonnage representing 27% of the 5,722,532 gross tons of shipping emanating from British yards. More than a quarter of every merchant hull that slid down a British slipway during the war came from this single river, and a very large proportion of those hulls were driven by three-cylinder Doxford economy engines, burning 6 tons of fuel per day at full speed, giving the convoys the endurance to make the North Atlantic crossing while keeping station with the faster American Liberty ships. The Doxford Engine Friends Association puts it without qualification. Most of these ships were powered by the famous three-cylinder economy engine, which saved Britain from starvation during the Second World War. The Luftwaffe understood the arithmetic too. Pallion was repeatedly bombed. The German targeting was precise. These weren't random raids on a port city, but deliberate attacks on the specific yards that were producing the engines that kept the convoy system alive. In 1941, King George VI visited the Wear yards, a morale-boosting visit specifically intended as recognition of their strategic value, of the fact that what the men at Pallion were building wasn't merely commercial shipping, but the physical means by which Britain ate. Imagine that for a moment. The King of England walking a shipyard floor in wartime, shaking the hands of the men who'd just built another three-cylinder diesel that would push another convoy through the U-boat corridor. The men weren't building warships. They weren't building Spitfires. They were building the thing that kept the country fed, and the country's head of state had come to tell them so. The yard had built destroyers in the First War, 21 of them, along with standardized merchant hulls, but it was the Second War that proved the strategic argument for the Doxford engine. A country that could design and build its own marine diesels didn't depend on foreign licenses for the engines that powered its merchant fleet. A country that couldn't, or that chose, through policy, to stop doing so, would be at the mercy of whoever controlled that technology. The lesson was there for anyone who wanted to learn it. Not everyone wanted to learn it. After the war, Pallion entered what would become the last great age of British commercial shipbuilding. Between 1946 and 1966, the yard alone completed 123 ships, including 23 tankers. The Doxford three-cylinder engine, now licensed to builders across the globe, was probably the most popular large marine diesel in service anywhere in the world. Through the 1950s and early 1960s, Doxford engines held between 25 and 30% of the global slow-speed marine diesel market. From the mid-50s onward, almost all of them ran on heavy residual fuel oil, the tarry, treacle-thick byproduct of refineries that nobody else could use efficiently. Marine diesel oil was needed only for starting and manoeuvring. At sea, a Doxford engine would drink the cheapest, nastiest fuel available and turn it into shaft horsepower with a thermal efficiency that made steam look medieval. The economy engine had been built for thrift in 1924. 3 decades later, its descendants were still the most frugal prime movers afloat. The post-war order book reads like a roll call of global trade. Bulk carriers for the coal and ore routes, tankers for the booming oil trade, general cargo vessels for the liner companies that still connected Britain to every port from Bombay to Buenos Aires. Clan Line remained a core customer. So did Ellerman, Blue Star, and a dozen other names that filled the shipping pages of the Financial Times. Each hull that slid down the Pallion ways carried a Doxford engine in its belly, an engine that had been designed on site, built on site, and tested on site before the ship ever touched water. Chapter 5. A Cathedral of Making. The photographs tell you more than any production statistic ever could. The Tyne and Wear archives hold a series taken in August 1954 inside the Doxford Engine Works. Reference ds.docs 6.11.9. In the sub-assembly shop, looking from east to west along the northerly bay, you can see a clear-span workshop with overhead travelling cranes, an industrial roof of riveted steel trusses, and rows of marine engine bed plates being fitted out. The scale is the first thing that strikes you. Each bed plate, the massive steel foundation on which the entire engine sits, runs the length of a terraced house. In the fabricating department, photographed the same day, workers are welding the bed plate of a 6-cylinder engine. The Doxford signature was all fabricated construction. The bed plates, columns, and entablatures were built up from steel plate by welding. not cast from iron in a foundry as Sulzer and Burmeister and Wain did it. It was a different philosophy, lighter, stiffer, and entirely dependent on the skill of the welders and fabricators who built each structure to tolerances measured in thousandths of an inch. A complete engine for a 1950s bulk carrier weighed between 200 and 500 tons and stood 3 stories high. Building one took months. The raw materials arrived by rail, bedplate castings from foundries on Tyneside and Teesside, forged crankshafts from suppliers such as the English Steel Corporation, cylinder liners cast in special iron. Pattern makers in the woodshop built full-scale wooden moulds for every major casting. Boilermakers welded the fabricated structures. Machinists in the heavy bay turned the crankshafts and bored the liners, work that demanded absolute precision, because a crankshaft running at 77 revolutions per minute in an engine designed to run for years without overhaul cannot tolerate even fractional imbalance. Fitters assembled the cylinders, pistons, fuel injection equipment, and camshafts, and then came the erecting pits, the iconic image of the Pallion engine works, the thing that made it a cathedral rather than merely a factory. The engines were stood vertically in deep pits cut into the workshop floor, assembled to their full height, and run on the testbed under Lloyd's Register supervision. The same 35-day endurance routine that had blessed Keller's 1914 prototype was still the standard. Every engine was proven before it left the building. The Doxford Engine Friends Association captures the scale plainly. Many Doxford engines were very big, the size of several 3-story terraced houses. The largest had cylinders bigger than 4 dustbins stacked end to end, and each of those cylinders was as powerful as 2 or 3 Spitfire engines. Stand in the erecting pit, looking up at a 6-cylinder Doxford stripped for trials, and you were looking at something that contained more controlled violence per cubic foot than almost any other peacetime machine in the country. When the test was complete, the engine was partially dismantled and craned across to the shipyard for installation in the hulls being built next door. The 2 operations, shipyard and engine works, sat on adjacent sites within the Pallion complex, divided only by a road. Steel arrived at one end of the covered shipbuilding hall. Finished ships, with engines installed and sometimes already turning over, came out of the other. It was vertical integration at industrial scale, and it existed nowhere else on the Wear. Every other yard bought its engines in. Doxford made the hull, made the engine, married the 2 together, and sent the finished ship down the river under its own power. The sounds of that process defined a neighbourhood, the rhythmic clang of pneumatic hammers on steel plate, the low, continuous hum of the overhead cranes, the intermittent crack of welding, bright enough to leave after-images through the darkened glass of a welder's mask. And underneath it all, when an engine was running on the testbed, a vibration that you felt through the soles of your boots, a deep, slow pulse, 77 beats per minute, as regular as a heartbeat, that told you the works was alive. The smell was machine oil and hot metal, with something else underneath. The sharp bite of cutting fluid, where the machinists were boring cylinder liners, and the acrid electrical tang of welding that hung in the upper reaches of the bay, where the ventilation couldn't quite clear it. On the rare occasions when the testbed was running on heavy fuel oil, you could taste it at the back of your throat, thick, petrochemical, unmistakable. A young apprentice arriving for his first shift in the 1950s would have walked through a complex that employed thousands. He'd have clocked in at the gate, crossed the yard, entered through one of the workshop bays, and been hit immediately by the noise, the heat, and the sheer scale of what was being built around him. The men who worked there were specialists, boilermakers, fitters, turners, pattern makers, welders, electricians, crane drivers, each trade with its own hierarchy, its own apprenticeship, its own union card. The pattern makers were the aristocrats. Working in the woodshop at the northern end of the complex, they built full-scale wooden moulds from which every major casting was made, moulds so precisely finished that the foundry could pull a clean impression first time. A pattern maker's tools were his own, carried in a chest that went where he went, and the skill was considered closer to cabinet making than to heavy engineering. Next door, the heavy machinists turned crankshafts on lathes large enough to occupy a room, working to tolerances that the pattern makers would have recognized as kin to their own. A crankshaft for a 6-cylinder J-type weighed several tons and had to be balanced to a precision that would keep it running at 77 revolutions per minute for years without overhaul. a standard that left no margin for approximation. A man didn't just work at Doxford's, he was a Doxford man, and the chances were that his father had been one before him. Chapter 6. The Wear at High Tide. The community around the works was distilled into specific streets, specific pubs, specific clubs. The Silver Grid in Pallion was the after-shift pub, the place where the day's work was discussed, complaints were aired, and the gossip of the yard was circulated with the efficiency of a well-maintained boiler room. Multi-generational families were the norm, not the exception. One Waresider, recalling his own family's connection, put it with the bluntness that comes from lived experience. My great-grandfather was a painter in the yards, my grandfather was a welder, my dad was a plater at Doxy's, and my uncle was a plater also at JL's. That pattern, grandfather, father, son, all walking through the same gates, was repeated across thousands of Sunderland households. It was the pattern that gave the town its identity. The Confederation of Shipbuilding and Engineering Unions was the umbrella under which the workers negotiated. Within it, the dominant unions at Pallion were the Boilermakers' Society, the Amalgamated Engineering Union, and the General and Municipal Workers. Trade union strength at Pallion was historically high, and the reason went back to William Theodore Doxford's explicit support for collective bargaining in the 1890s. Other yards on the Wear had adversarial industrial relations, bitter disputes, lockouts, grudging settlements. At Pallion, the relationship between management and organised labour was functional, not perfect, but functional in a way that both sides understood had been built deliberately, across decades, and that neither side was willing to throw away lightly. The town that the yard sustained was, by the mid-20th century, one of the great industrial communities of the English northeast. Sunderland had been credibly described as the largest shipbuilding town in the world, a claim first made by the Sunderland Herald in 1850, repeated in official industry publications through the 1940s, and defended by J. Ramsay Gebby of the Ware Shipbuilders Association in his foreword to Where Ships Are Born, published in 1947, the year after VE Day. The safer phrasing is, at various times in the 19th and 20th centuries, the largest shipbuilding town in the world. But the point held, this wasn't a city that happened to build ships. This was a city that existed because it built ships, and at the centre of it, the largest yard on the river, was Pallion. The engine works, the only British facility designing and manufacturing 100% domestically developed two-stroke marine diesels, gave Doxford a position that no other Ware shipbuilder held. Thompson, Laying, Austin and Pickersgill, Bartram, Short Brothers, all of them were significant yards, all of them built ships that sailed on every ocean, but none of them made their own engines. None of them held a portfolio of 25 international licensees. None of them could claim that roughly a third of the world's installed slow-speed marine diesel power carried their name on the crankcase. That distinction mattered beyond Sunderland. When the Ministry of Defence calculated Britain's strategic industrial capacity, the Pallion Engine Works was one of the facilities on the list. When Lloyd's Register published its annual statistics on installed marine diesel horsepower worldwide, the Doxford name appeared alongside Sulzer and Burmeister and Wain as one of only 3 major slow-speed engine designers in the Western world. It was a position earned over 60 years, engine by engine, license by license, Lloyd's test by Lloyd's test, and it rested on a design office of perhaps 30 engineers in a town that the rest of England barely thought about. The technical engine of the post-war golden age was the P-type, introduced in the mid-1950s. 48 P-types were built at Pallion and under license by Hawthorne Leslie and Chantiers de Provence. In 1962, when it became clear that scaling the P-type beyond 6 cylinders was impossible, the long crankshaft developed torsional vibration problems that no amount of damping could solve. The chief designer, Percy Jackson, set about a successor. Jackson was by then the most respected English oil engine designer of his generation, a man whose experience ranged from small, high-speed engines to the giant direct-drive marine units that powered supertankers. His paper, The Future Doxford Marine Oil Engine, delivered to the Institute of Marine Engineers in 1961, set out the case for a new, stiffer crankshaft and 3-piece cylinder construction. The result was the J-type, introduced in 1965. After initial problems with the centre crosshead bearing and the combustion belt were resolved, 103 J-type engines were ultimately built. The largest, a 9-cylinder unit producing 30,000 brake horsepower, was fitted to the tanker North Sands in 1966, marking the operational merger of the Pallion and North Sands yards under the Doxford and Sunderland banner. The biggest J-type ever constructed was the 9-cylinder engine installed in the 135,000-ton bulk carrier Orenda Bridge in 1972. Among the engineers who carried the J-type forward was a team of remarkable depth. George Jackson, Percy's son, continuing the family tradition that ran through every level of the firm, Frank Butler, Henry Henschel, David Stables, Brian Taylor, and a Norwegian-born specialist named Dr. Finn Urbeck. Urbeck had earned his PhD at the University of Glasgow in 1957, with a thesis on torsional vibration of crankshafts, joined Doxford from Det Norske Veritas in 1959, and would become the last gifted head of Doxford's design office. He was, in a sense, the spiritual descendant of Carl Otto Keller, a foreign-born engineer who'd come to Pallion because Pallion was the place where opposed-piston diesel design was being done at the highest level. Chapter 7. The highest point before the cliff. By the early 1970s, Pallion had never been more physically impressive. The yard held 9 building berths. The engine works was producing J-type diesels for ships of every size, from feeder container vessels to supertankers. The workforce exceeded 7,500, and between 1973 and 1976, Courtline, the London-based conglomerate that had taken over the Doxford and Sunderland group in 1972, invested £36 million in a complete rebuild of the East Yard, demolishing the old berths to make way for a covered shipbuilding hall that was, by any measure, one of the most advanced facilities in Europe. The new hall was 181 metres long, 50 metres wide, and 32 metres high, large enough for 2 ships of 30,000 tons dead weight to be built side by side, entirely under cover, protected from the North Sea weather that had plagued open-air construction on the Wear for centuries. Steel arrived at one end. Finished ships came out the other. The covered hall was the physical expression of a bet that British shipbuilding could compete with Japan and Scandinavia if it modernised hard enough and fast enough. Look at that facility in 1976, and you saw the future. A vertically integrated shipyard and engine works, building domestically designed hulls powered by domestically designed engines, in a covered hall that eliminated weather delays, with a design office staffed by engineers, Urbeck, Butler, Henschel, Stables, Taylor, who were already working on the next generation of opposed-piston diesel, the 58J S3, a short-stroke engine that promised more power per cylinder, higher revolutions, and a step change in competitiveness against Sulzer and Burmeister and Wain. The drawings were on the boards. The testbed schedule was set. The future was being designed in the same building where Keller had proved the first prototype in 1914. In 1978, the workforce at the combined Pallion shipyard and engine works numbered 7,535. It was the largest single industrial employer on the Wear. It was, by a wide margin, the most technically capable, and it was about to be handed to a government that had no intention of keeping it alive. But that is a story for the next chapter, and it does not begin with a foreign competitor or a technological failure, or even the 1973 oil price shock that had already cut the heart out of the world freight market. It begins in a London courtroom in August 1974 with the collapse of a holiday company. Chapter 8. The holiday company Courtline Limited was a London-based conglomerate whose primary interests were aviation and package holidays. It ran Clarkson's Holidays. It operated BAC 111s painted in bright pastel colours, turquoise, lilac, lemon yellow, flying British families to the Mediterranean. It was, in the language of the early 1970s, a leisure company. And in 1972, it bought the Doxford and Sunderland shipbuilding group. The logic, if there was logic, was diversification. Courtline put £36 million into the Pallion East Yard rebuild, the covered shipbuilding hall, the most modern facility on the Wear, the physical expression of the bet that British shipbuilding could still compete. But Courtline was not a shipbuilding company. It did not understand the industry's cycles, its cash requirements, or the structural forces that were already closing around it. What it understood was balance sheets, and the Doxford balance sheet looked, for a brief moment in the early 70s, like an asset worth holding. Then, in August 1974, Court Line collapsed. The debts were massive. The holiday business had been hemorrhaging cash, and the shipbuilding and marine engine interests had been milked. Tony Benn's word, not a historian's, to prop up a company whose core business was sending families to Benidorm. A private enterprise company, Ben called it, that had been milking its shipbuilding, repairing and marine engine interests to prop up a holiday company. The diagnosis was precise. The treatment was nationalisation. Ben took the shipbuilding assets into public ownership. The yard at Pallion would, in the bitter judgment of Sunderland MP Bob Clay 13 years later, not be there now were it not for my right honour's friend the member for Chesterfield, meaning Ben. It was the second time Pallion had been rescued from collapse by direct state intervention. The first, during the wartime command economy, had been a rescue that led to the yard's finest hour. This rescue would be the prelude to its extinction. But Court Line's collapse was only the most dramatic of three forces that had been gathering since the late 1960s. The first was containerization. The breakbulk tramp ship, the vessel type that Doxford had been building and powering for 60 years, was being displaced by container ships at a speed that caught the entire British merchant shipbuilding industry off guard. Containers demanded different hulls, different port infrastructure, different engines. The three-cylinder economy engine that had carried a 10,000-ton tramp across the Atlantic on 6 tons of fuel was irrelevant to a container vessel doing 20 knots on a fixed schedule. The market that Doxford's engine had been built to serve was vanishing. The second was the 1973 OPEC oil price shock. Freight rates collapsed. The world order book for new merchant ships contracted violently. The British shipbuilding industry experienced what one historian called the worst depression since the early 1930s, and it arrived at the precise moment when the industry was least equipped to absorb it. Overcommitted to capital investment, undercapitalized for a downturn, and facing competitors who could ride the storm because their governments were willing to subsidize them through it. The third, and ultimately the most lethal, was Japan. By the late 1970s, Japanese yards, Mitsubishi Heavy Industries, Mitsui, Hitachi Zosen, IHI, were quoting prices as much as 60% lower than British tenders. The productivity gap was devastating. Sir Robert Atkinson, the second chairman of British shipbuilders, would later quantify it with a brutality that left no room for consolation. Britain needed 50% more man-hours to build a bulk carrier than its competitors. Even if our men worked for nothing, he said, and we paid no rent or rates or overheads, we could not match them. The Japanese advantage was not simply cheap labour, it was systematic: better planning, better steel supply chains, better integration of design and production, and a government that viewed shipbuilding as a strategic export industry worth subsidising through downturns. And alongside the Japanese, 2 European engine builders had been steadily eating Doxford's market. Sulzer Brothers of Winterthur, Switzerland, had been in the marine diesel business since before 1910 and had licensed widely in Britain. Walls and Slipway, George Clark of Sunderland, Vickers Armstrongs. Their RTA series would remain dominant into the 21st century. Burmeister and Wain of Copenhagen had supplied Harland and Wolff with B&W engine licenses since 1911. By the late 1960s, B&W's poppet valve two-stroke had become the global default for new construction. In 1980, the same year Pallion built its last engine, B&W diesel was sold to MAN of Germany, creating MAN B&W diesel, which by the year 2000 held over 70% of the world market in two-stroke marine diesels. Doxford's J-type, for all its engineering quality, had a specific weakness that the competitors exploited. A 1988 paper to the Institute of Marine Engineers found that J-type fuel consumption was approximately 7% worse than equivalent B&W and Sulzer engines, due to the Doxford's relatively low compression pressure. 7% doesn't sound like much. On a supertanker burning 100 tons of fuel a day, it was the difference between winning an order and watching it go to Copenhagen. And then there was the licensing decision that may have mattered more than any technical shortcoming. The Pallion board, fearing that expanding the J-type licensee network would create competitors who would undercut British shipbuilders, deliberately restricted the number of new licensees at the very moment when more licensees might have created the scale needed to compete with Sulzer's global network. It was a decision made from a position of weakness dressed as caution. The intended scale never materialized. The market went elsewhere. By the time Court Line collapsed and the state stepped in, the yard was caught between forces it could not control and decisions it would not be allowed to make for itself. Chapter 9. The Engine They Killed. The Aircraft and Shipbuilding Industries Act received royal assent on the 17th of March, 1977, and only under the provisions of the Parliament Act, after 3 rejections by the House of Lords and an infamous incident in which Michael Heseltine seized the mace in the Commons chamber in protest. Nationalisation was not a consensus. It was a political act forced through against opposition, and the industry it created, British shipbuilders, headquartered at Benton House, Sandyford Road, Newcastle, inherited everything: 32 shipyards, 6 marine engine works, 6 general engineering plants, and approximately 87,000 employees. On the 1st of September, 1977, Doxford and Sunderland's assets were vested in the new corporation. The Pallion engine works, the only facility in the country designing and manufacturing a wholly British slow-speed marine diesel, was assigned to the engineering division. The first chairman was Admiral Sir Anthony Griffin, whose remit was rationalisation. His successor, Sir Robert Atkinson, appointed in 1980, would close half of British shipbuilders' yards by the end of 1982. Atkinson was a Tynemouth-born former corvette captain who had won 3 Distinguished Service Crosses in the Battle of the Atlantic. A man, in other words, who had risked his life to protect the very convoy routes that Doxford engines had powered. He was fiercely patriotic. He famously banned Japanese cars from his yard's car parks, a gesture that was simultaneously defiant and absurd, given that his corporation was losing market share to Japanese shipbuilders at a rate that no car park policy could address. He set himself the goal of making British shipbuilders profitable by 1984. To do it, he split the corporation into 5 trading divisions: merchant shipbuilding, warship building, engineering, ship repair, and offshore. Each division was expected to justify its existence commercially. Each was measured against a profitability target that bore no relationship to the long-term investment cycles of marine engineering. But the engineering division had a problem it could not solve within the constraints Atkinson imposed. The J-type was a known design that had become commercially uncompetitive. 2 attempts to break out of the trap had been made, and both had ended in failure. The first was the Doxford Seahorse, a 580mm bore, 4-cylinder medium-speed engine, geared rather than direct drive, developed as a joint venture with Hawthorne Leslie. A wooden mock-up was displayed at a marine exhibition in London in 1972. The industry press, with the casual cruelty of journalists who know a dead project when they see one, nicknamed it the Wooden Horse. A prototype was built and produced 1,850 kilowatts per cylinder. No commercial orders ever materialized. The Seahorse was quietly abandoned, an engine that existed as a mock-up, a press release, and a lesson in how not to launch a product. The second attempt was the one that mattered. The 58JS3. Design work began in autumn 1976, drawing on the Seahorse's technology but applied to a fundamentally different concept: a short-stroke version of the J-type, 580mm bore, 880mm lower piston stroke, 360mm upper piston stroke, running at 220 revolutions per minute. Each cylinder produced 1,350 kilowatts, a considerable advance on the conventional J-type of the same bore. The plan was to offer it in 3, 4, 5, and 6-cylinder versions, with 670 and 760mm bore variants to follow. The design team was the last great concentration of opposed-piston diesel expertise in Britain: Frank Butler, Henry Henschel, George Jackson, David Stables, Brian Taylor, and Finn Urbeck. These were men who had spent their careers, in Urbeck's case, nearly 20 years since joining from Det Norske Veritas, refining and developing the Doxford engine. The 58JS3 was their bid to prove that the opposed-piston principle could compete with Sulzer and B&W into the next century. The first 58JS3 completed test bed trials in 1978, producing 4,050 kilowatts at 220 revolutions per minute. Doxford convinced 2 ship owners, Furness Withy and Ellerman Cityliners, to take the new engine. 7 units were built for feeder container ship propulsion. The first was installed in the 300 TEU city of Plymouth, built by Appledore shipbuilders for Ellerman. Only 10 3-cylinder units were ever produced, and then the decision was taken. by British Shipbuilders Engineering Division with the approval of the corporation's chairman Sir Robert Atkinson, engine production at Pallion was terminated. The 58JS3 programme was cancelled. No further development would be funded. No further engines would be built. The official rationale was commercial. The engine wasn't selling in sufficient quantities. The larger J-type's fuel consumption was uncompetitive, and the engineering division was hemorrhaging cash. 10 engines in 2 years, against a world market dominated by Sulzer and B&W and a domestic customer base that was itself contracting towards extinction. The numbers, viewed from Benton House, didn't work. Viewed from Pallion, the numbers told a different story. 10 engines was a first production run, not a market test. Every new marine diesel in history had taken years to build a customer base. Sulzer's first engines had taken a decade to establish. B&W had spent years building its licensee network before commercial traction arrived. The 58JS3 needed development time, marketing investment, and a licensee program that would give it the global footprint to compete. What it got instead was cancellation. After less than 2 years of production, with a test-bed engine that had proved the concept and a design team that was already working on the larger bore variants that would have made the engine competitive across the full range of merchant ship propulsion. The bitterness among the engineers was intense, and it never fully healed. Forum recollections from former Doxford staff, recorded years later, carry a specific anger directed not at the principle of rationalization, but at the manner of the killing. A new technical director wishing to make his own mark in the business, one engineer wrote, identifying the corporate politics behind the decision. Others pointed to the licensing restrictions that had stifled J-type sales. The deliberate refusal to license widely for fear of creating competitors, which had the paradoxical effect of ensuring that the engine never achieved the installed base it needed to survive. The design was respected. The engineers were capable. What was missing was institutional will, and institutional will had been vested since 1977, not in Pallion, but in Newcastle, in Benton House, in a corporation whose remit from the incoming Conservative government was not long-term development, but rationalisation, privatisation of what could be sold, and closure of what couldn't. A marine diesel programme that might not turn a profit for a decade did not fit that remit. The men on the drawing boards at Pallion understood this. They also understood that if the programme died, it would not come back. You cannot mothball a design capability. When the engineers leave, the knowledge leaves with them. When the testbed goes cold, the institutional memory of how to develop an opposed-piston diesel, the accumulated understanding of combustion dynamics, piston ring wear, scavenging efficiency, crankshaft torsional behaviour, doesn't wait in a filing cabinet for someone to pick it up again. It disperses. It's gone. The last new Doxford engine number 477, a 4-cylinder 76JC4R J-type, rated at 9,000 brake horsepower, was completed at Pallion in 1980 and shipped across the Atlantic to Port Weller Dry Docks in Ontario. It was installed in the Great Lakes self-unloading bulk carrier Canadian Pioneer, 730 feet long, 24,113 gross tons. She sailed for the Upper Lakes Group under the British flag until December 1988, then as Pioneer under the Vanuatu flag, and was finally beached at Alang in India for scrap in July 2014. The last Doxford engine ever built left Britain in a crate, crossed an ocean, and spent its working life on a Canadian lake. After 1980, the Pallion Engine Works ceased new production. It became a spare parts operation, the erecting pits that had stood engines 3 stories high, now used to service components for an aging fleet of Doxford-powered ships scattered across the world's oceans. The design office continued in reduced form, a handful of engineers maintaining technical support for licensees and operators who still needed drawings, who still needed advice on combustion beltware or piston ring replacement for engines that had been running, in some cases, for 20 or 30 years. Finn Urbeck stayed on, then eventually founded Orion Technology on Wareside, a small consultancy that functioned as a kind of marine engineering diaspora, the last trace of the design capability that had been concentrated at Pallion for 70 years. Of the 25 worldwide Doxford licensees, not one picked up the design. Not one. 25 companies in a dozen countries, all of which had built Doxford engines under license, all of which possessed the drawings and the manufacturing capability, and not one of them judged the opposed piston diesel worth continuing. The B&W and Sulzer two-stroke engines, both poppet valve uniflow rather than opposed piston, had already won. The opposed piston principle, elegant, mechanically simple, thermally efficient, would survive only in niche military diesel applications and a handful of experimental programs. The Doxford engine works, the only British works ever to design, develop and build a slow-speed marine diesel from a clean sheet, was a museum within a decade. The yard, stripped of its most distinctive technical capability, stumbled on. Chapter 10. Murder at the Dispatch Box. For the rest of the 1980s, the Pallion shipyard limped forward under names that changed faster than the order book could fill. Between 1981 and 84, it built 7 B-30 bulk carriers. It moved into the North Sea oil services market, taking orders from Stena Line of Sweden for 2 large oil well maintenance ships. In February 1986, it was merged with the Austin and Pickersgill Yard at Southwick into a new entity called North East Shipbuilders Limited, NESL, and set up for privatisation under the British Shipbuilders Act of 1983. The merger was supposed to create viability through scale. What it created was a larger entity losing money faster. The yard that had once designed its own engines, built its own hulls, and launched the highest tonnage in the world, was now a subcontractor, building ships designed elsewhere, powered by engines made elsewhere, to specifications set by customers who could, and increasingly did, place the same orders in Korea or Japan for half the price. The only major contract was for Superflex Ro-Ro ferries for Danish interests, negotiated through PZ Trading of Næstved. Originally 24 ships, later cut back to 14. The contract was financially catastrophic. At fixed prices in an environment of rising costs, with disputes about specification that dragged on for months, NESL lost an estimated £100 million on the build over 3 years. £100 million, on a contract that was supposed to keep the yards alive. The ships were being built, the welders were welding, the cranes were turning, and with every hull that went down the ways, the company lost more money than it would have lost by doing nothing at all. The workforce, which had numbered 7,535 in 1978, had fallen to about 2,000. On Wednesday, the 7th of December, 1988, at 3:30 in the afternoon, the Chancellor of the Duchy of Lancaster and Minister of Trade and Industry, Tony Newton, rose in the House of Commons. Hansard records the statement in volume 143, columns 315 to 330. It is the document that ended 6 centuries of shipbuilding on the Wear. Reluctantly, and with great regret, I therefore have to tell the House that I see no further realistic prospect of maintaining NESL in its present form, and its shipbuilding yards will therefore progressively close as the current workload runs out. Newton's reasoning was financial. NESL had cost the taxpayer almost £2 billion, including losses of about £650 million, of which at least £100 million had been lost in the past 3 years, merely by fulfilling contracts to build ships. In compensation, he offered an enterprise zone with 10 years rates relief, £7 million for advanced factory space, and £10 million over 3 years for retraining. £45 million in total. For a town that was about to lose its reason for existing. The response from Sunderland's Labour MPs was immediate and incandescent. Chris Mullin, the member for Sunderland South, a recently elected investigative journalist who would later become one of the most respected backbenchers of his generation, rose and said what the town was thinking. Sunderland has been murdered today, in the same way as Jarrow was murdered by a predecessor government in 1934. Before today's announcement, male unemployment in Sunderland was running at over 20%. There are whole streets where almost no one is working, and generations of children are growing up who may never work. This closure was not inevitable. Orders could have been obtained, the Cuban order, for example, but no serious effort was made to obtain them. He asked what would happen to the assets. This is one of the most modern shipyards in Europe. Will its assets be looted or mothballed against the day when perhaps it is possible to revive shipbuilding on the Wear? Bob Clay, the member for Sunderland North, a former bus driver and shop steward who had been working for weeks with a worker management consortium, had a specific grievance, and he delivered it with the directness of a man who had just watched something he'd fought for be destroyed. He and the consortium had assembled a rescue bid built around a £110 million order from Cuba for 10 mixed cargo ships and 10,000 containers. A 5-year cooperation deal. Real ships, real work, real money. He has destroyed the work of the past 600 years and any possible future for Sunderland, Clay told the minister. Will he stop the murder of the yard, which is on the point of benefiting from that upturn, and prevent the murder of the town? Newton, in a rare concession, paid Clay a compliment. I have the greatest respect for the efforts that he has made in recent weeks to bring forward a package that would enable us to secure a future for the yard. The answer was no. John Garrett, speaking for the Labour front bench, called it the destruction of the Sunderland economy and the death of British merchant shipbuilding. This act of industrial vandalism not only brings to an end 600 years of shipbuilding on the Wear, but destroys an essential British industry. The Speaker, Bernard Wetherill, repeatedly called for order over Labour interruptions. Charles Slater, the leader of Sunderland City Council, had warned weeks earlier what was coming. If closure takes place, we will support any rescue effort made in the form of a package, but it will have to be a good one, not 25 million or 30 million. We are looking for hundreds of millions. It would be an act of economic vandalism, unparalleled in the history of this country, to destroy the 2 most modern shipyards in Europe. He was overruled. The widely believed explanation in Sunderland, and a charge to which the government never gave a fully convincing answer, was that the closure was the British end of an EEC bargain. Govan Shipbuilders on the Clyde was sold to the Norwegian group Kvaerner in 1988, and many in Sunderland believed that an EEC condition for saving the Clyde was the elimination of Wareside merchant shipbuilding capacity. Sir Robert Atkinson, by then a year out of office, had told the Sunderland Echo in July 1988 that the industry was at a critical point beyond which it could not survive. He blamed the government's lack of commitment to the industry's success. The broad shape of that belief, that an EEC restructuring agreement bound the British government to reduce capacity, was consistent with the conditional grant funding that subsequently flowed. Sunderland's yards were traded away to save Glasgow's. The Wear, which had launched ships since 1346, was sacrificed in a negotiation conducted in Brussels between governments that measured success in capacity removed. 2 days after Newton's statement, on Friday the 9th of December, Superflex Kilo floated out of the Pallion covered building dock, the last newly constructed ship ever to leave the facility. She was renamed Mercandia Y and went into service in Danish waters, a ferry built in Sunderland, sailing Danish routes, because the yard that built her could not find enough British or international owners willing to order ships from a facility that the British government had publicly condemned to closure. 3 days after that, on Monday the 12th of December 1988, Superflex November left the ways at the Southwick Yard, the last ship ever launched on the Wear. The press recorded it plainly. December 12, 1988, saw the final ship to be built on the Wear slide down the slipway on a bitterly cold winter's night. The chill which affected onlookers not only came from the plunging temperature, but from the realization that an industry which had sustained Sunderland for centuries had disappeared. The men who stood on the quayside that night, the welders, the fitters, the platers, the electricians, the crane drivers, the foremen, were watching the end of something that had defined not just their working lives, but their family histories. Grandfather, father, son. The pattern that had repeated across thousands of households for a century and a half, broken in a single parliamentary statement delivered at 3:30 on a Wednesday afternoon by a minister who had never set foot on the shop floor at Pallion. 6,000 shipyard workers lost their jobs. Chapter 11. What the River Remembers. The demolition contractors moved into the Southwick Yard within months. The cranes came down first, the structures that had been visible from miles away, that had marked the Wear's industrial skyline for generations, dismantled and sold for scrap. North Sands was bulldozed and the site given to the University of Sunderland for a new campus, lecture theatres where the fitting-out berths had been, seminar rooms where the paint shops had stood. The Pallion-covered hall, sold to an Anglo-Greek consortium as Pallion Engineering, was mothballed, intact, but never again allowed to build ships. EEC funds reportedly came on condition that no new shipbuilding take place on the Wear for 10 years. The most modern covered shipyard in Britain, built at a cost of £36 million, barely 15 years earlier, was prohibited from doing the one thing it had been designed to do: The retraining grants arrived. £45 million in EEC money for retraining and inward investment. The word retraining was heard often in Sunderland in 1989 and the years that followed. It carried a particular inflection, the suggestion that the problem was not the absence of work, but the inadequacy of the workers, that what a boilermaker with 30 years' experience needed was a course in computing or customer service, and that the skills he already possessed, the ability to weld a marine engine bedplate to tolerances measured in thousandths of an inch, were no longer considered skills at all. By 1987, the borough had already lost a net 16,000 jobs since 1980. The Nissan plant opened on the 8th of September 1986 on the former RAF Usworth airfield, Margaret Thatcher and Nissan president Yutaka Kume cutting the ribbon together, a Japanese car manufacturer arriving on a Sunderland airfield to replace what British shipbuilding had been, offset some of this, not most. Nissan at peak employed around 5,000. The shipyards, at their collective peak, had employed many times that number, and the Nissan jobs, for all their value, were assembly jobs. Nobody at Nissan Sunderland was designing an engine from a clean sheet. Average wages in Sunderland, which had been 79% of the British average in 1983, did not recover. Hidden unemployment, people on incapacity benefits rather than registered as jobless, persisted at among the highest rates in the country well into the 21st century. The shipyard jobs had been skilled, unionised, and relatively well paid. What replaced them, where anything replaced them at all, was not. The former Doxford engine works was for years occupied by W.H. Forster, a printing firm. The Doxford Gates, the old entrance to the yard, stand today as a monument near the realigned approach to the Northern Spire Bridge, the £117 million crossing that opened in 2018. The gates mark a boundary. On one side, the 21st century. On the other, the memory of what the 21st century replaced. Of the more than 1,750 Doxford engines built in Sunderland and under licence over 66 years, only one is known to remain in regular sea service as of the mid-2020s, the engine of the Abern Ice, a drill ship originally built in France in 1959 as the Jean Schneider. The last UK-built Doxford in regular service, the Hawthorne-Leslie-built engine of the Great Lakes Laker Algoma Navigator, was scrapped in the mid-2020s. 3 preserved engines survive. The largest single-cylinder Doxford ever made, the experimental unit from the Palmer's Hill Works, donated to South Shields Marine College in 1969, has been moved to the Anson Engine Museum at Poynton in Cheshire. The Doxford Engine Friends Association is working to reassemble it to running order. If they succeed, it will be the only running survivor of the type in the world. One engine, in a museum, in Cheshire. That is what remains of the technology that powered a third of the British merchant fleet through the Battle of the Atlantic. The Pallion shipbuilding hall still stands. It is the only fully enclosed shipyard on the east coast of Britain. It is used for ship repair, fabrication, and offshore work. Occasional protest campaigns, most recently the Pallion Shipyard Partnership in 2022, demand its return to active shipbuilding. The hall is there, the cranes are there, the covered dock is there. What is not there is the permission, the investment, or the political will to use them. Patricia Richardson's 2018 book, William Doxford and Sons Limited of Sunderland, Shipbuilders and Engineers, 1837 to 1988, is the standard family history. Her husband, Michael Richardson, is the great-great-grandson of Richard Doxford. The book is careful, thorough, and it exists because one family decided that if nobody else was going to write the record, they would do it themselves. In June 2016, Sunderland became the first city in Britain to declare its EU referendum result. 82,394 votes, 61.3%, were cast in favour of leave. It was the first result of the night, and when it flashed on the screens in the BBC studio, the presenters visibly recalculated. The polling had predicted a narrow Remain victory nationwide. Sunderland's margin said otherwise. The vote was, by general consensus of subsequent commentators, a long-deferred verdict, not on Europe, not on immigration, on what had happened on the Wear in 1988, and in the years before and after, on the sense, held across an entire community for a generation, that decisions had been made in London about their lives, and that nobody had asked them, and that the people who made those decisions had never once walked through the gates at Pallion to see what was being built there, or to understand what it would mean when the building stopped. The river still runs through Sunderland. It runs past Pallion, past the covered hall, past the site where the engine works stood. It runs past the place where William Doxford built his first wooden ship at Cox Green in 1840, and past the place where Superflex November slid down the ways on a cold December night in 1988. The river doesn't remember. But the town does.